Okay, this is the final project presentation for light density sensitive light. The lecturer of the subject is Dr. Muhammad Azrai bin Muhammad Razman, course code BTO 1313, section 01 by Fatima Mari bin Roslan, Nur Hati binti Rusli, and me, Muhammad Asbifan bin Abdullah. The description of our project is the light detector sensor mini is a simple yet powerful concept that uses a photoresistor as the light system. By using this system, the brightness of the bulb or lamp depends on the photoresistor. When the surrounding is dark, the brightness of the bulb will increase, and if there is any light, the brightness of the bulb or lamp will decrease. By using this, energy consumption can be reduced. The system can be found in many consumer items such as solar street lamps, night lights, and many project photoresistor detectors.
So this is the schematic design of our project on Proteus. So the project uses Arduino Uno R3, two push buttons, an LDR photoresistor, a yellow LED 100 ohm resistor, and three 1000 ohm resistor, and a DC motor. So next.
Okay, so here's the simulation of the project on both Tinkercad and Proteus. Uh, so as you can see here, um, both designs on Tinkercad and Proteus works well. So how does the design work? Firstly, connect the Arduino Uno to the power supply, turn on the system's LED red light. Photoresistor detect light density of the surroundings, and multimeter receive readings from the photoresistor, and the DC motor is running.
So this is the flowchart of how our design and project works. So when we start the circuit, the power supply will be turned on, and the multimeter and the push button will both turn on. When we push the push button, the start push button, the LED red light will, will turn on. And if it doesn't turn on, then the circuit will end there. If the LED light turns on, the photoresistor will detect the light, and if it does, the DC motor will turn on and the multimeter will read its high value. After that, the high light density will be detected. If the light cannot be detected, we will go back to the push button part. We will try again until we can get to the desired result. So next.
So we move to the video Arduino physical. On the below we have the circuit, the video of circuit on how the circuit is processed. On the left side we have the picture of the circuit before the power supply is connected. So when the power supply was turned on, the switches. So let's take a look on the graph that we have made from the Visual Studio and the circuit. Okay, so basically when the power is connected and the switch is turned on, the graph will increase and decrease. The increase indicates that the higher the voltage needed to light up the LED bulb, which is, in other words, the photoresistor receive low light intensity, or in other words, the surrounding is dark, so it need high voltage to light up the LED bulb. Other than that, if the graph is decreasing, it require low voltage or power to light up the LED bulb, so the brightness of the LED bulb will decrease because the surrounding is already have high light intensity. So this is the coding for the GI Visual Studio for the graph and how the graph will start. We use CLR format as the format to make the graph. Next.
So this is the cost of material used for our project. So first of all, we bought Arduino Uno R3 set, which cost 49 ringgit and 40 cents. And the components that we use from the set is Arduino Uno, 2 push button, 1 photoresistor, 1 red LED, and 1 mini breadboard. Next, we bought one resistor 100, which costs 1 ringgit, and one 1K resistor. We bought like 3 of them, so it costs like 3 ringgit. And we also bought a DC motor, which costs 2 ringgit 90 cents. We also bought one set of jumper wire, which costs 3 ringgit and 49 cents. After roundings and everything, total cost of our project is 59 ringgit and 80 cents. And that's all for our presentation. Thank you.